Thank you everyone. Today I discuss about sinking and flotation of a solid object inside the or into the liquid. When a solid object is immersed into the liquid fully, then two forces acts on that object simultaneously. One is the buoyant force, acts in upward direction, vertically upward direction. Another is the weight of that object, acts vertically downward direction. Say it is liquid. A solid object is immersed fully into that solid. Then liquid exerts an upward force from the point of buoyancy, here the B, point of buoyancy in upward direction, which is known as the buoyant force, and it is indicated by WB. This buoyant force is equal to V dl into G. V, it is the volume of the immersed object. dl, it is the density of liquid. G is the acceleration due to gravity. Now another force, it is the weight of the object. It acts on the object in downward direction and from center of gravity. Say here the center of gravity C. The weight of the object acts in downward direction and it is say W, weight of the object. It acts from C in downward direction. Buoyant force WB acts in upward direction from the point B, that means center of buoyancy. Weight, it is measured by the formula V ds into G. That means V is the volume of the solid, ds is the density of the solid, and G the acceleration due to gravity. So these are the two formulas for the buoyant force and the weight of the object, and these two forces simultaneously act on that immersed object. Now there are three possible conditions or three possible relations between this buoyant force and weight of the object. What are they? Three possible conditions. Or relation. Three possible relations. Number one, weight of the object is greater than the buoyant force. Second one, buoyant force WB is greater than the weight of the object. Third one, buoyant force on the object is equal to weight of the object. Remember, here the weight of the object means the true weight of the object, not apparent weight of that object. Now we discuss about when W, that means weight of the object, is greater than the buoyant force acts on the object. Now what happens? Here this is the solid. The weight acts on the object. It is the V ds G in the downward direction from center of gravity, and another is point B. From B, the buoyant force WB acts in upward direction, and it is V dl g. Now what happens? Here the W is greater. This is W is greater than WB. As W is greater than WB, then a net resultant force acts on the object in downward direction. That means a resultant force acts on that object in downward direction, and it is W minus WB. This resultant force acts on the object in downward direction as W is greater. Then what happens? As the downward force is greater and resultant downward force acts on the object, then the object tends to move in downward direction, and the object tends to sink. And then what happens? It is the W is greater than WB. W is this is. That means V dsg is greater than WB. WB is V dlg. This is the condition. Here the V and V from the both side, G and G from the both side cancel. So here the ds is greater than dl. That means if the density of solid is greater than the density of liquid, then the object tends to sink. That means if you release this object, then the object goes down and sinks to into the solid. This is the first condition. Now the second condition. What was the second condition? Here the second condition was WB, that means buoyant force, is greater than weight. Second condition, here the WB is greater than W. Now what happens here? This is the liquid. One object, solid object, is immersed into it. The weight of the object acts in downward direction, and it is W, and it acts from point C, and W is equal to V ds into G. Now another force, buoyant force, from center of buoyancy, it acts in upward direction, and it is WB, and the formula for WB is V dl into G. So here WB and W, these two forces acts on the object simultaneously, but here the WB is greater. As the WB is greater, that is why then a resultant upward force acts on the object, and this resultant upward force will be WB minus W. This amount of upward resultant force acts on that object. As the upward resultant force acts on the object, then this resultant force pushes the object in upward direction, and the object tends to float on the liquid surface. That happens when here the WB means this is V dlg is greater than weight. Weight means this V dsg, V dsg. From both sides V and G are cancelled, so dl is greater than ds. That means if the density of liquid is greater than the density of solid, that means density of solid is less than the density of liquid. That in other words, if the solid is lighter than the liquid, then it tends to float. But if it released, then what happens? It goes to the upper layer of the liquid and floats there. Now the third condition. What is the third condition? Third condition is here the buoyant force and the weight of the object, these two are equal. That means the third condition, it is the WB and W, these two are equal. That means here this is the solid, the buoyant force WB is in upward direction, and from point B and from point C the downward direction the weight. These two forces acts simultaneously, and it is the V dlg and it is V dsg. As these two forces are equal, then no net resultant force acts on the object. As no resultant force acts on the object, then the object does not move in any direction. It does not move in upward direction, it does not move in the downward direction. That means it remains at that place where it is kept. That means, and it is known as the flotation of the object of the solid inside the liquid. That means object remains here. If you put the object here, if you put the object here, then the object remains here. Now when it will be V dlg equal to V dsg, from V G G are cancelled from the both sides, dl equal to ds. That means when the density of solid and density of liquid both are equal, then it happens. It happens means the solid floats inside the liquid where it is kept. So for the two conditions the object floats. One is the float inside the liquid and another is the float the upper layer of the liquid. The first condition is W B equal to W, and the another is the W B is greater than W. If these two conditions, any one of these conditions maintained, then the object float in the liquid. Here it is the inside the liquid, here the object tends to float in the upper layer of the liquid. Now when the object floats, that means the already object floats in rest. Say here this is the container, I take the liquid here. The object can float like that. One part of it remains inside the liquid and one part of the liquid solid remains outside the liquid. It can float like that, and or it can float like that. That means inside the liquid, totally floating. These two are the floating condition. That means object floats. When the object floats, then its buoyant force and the weight, that means true weight of the object, both are equal. That means here the W and WB both are equal. Here the immersed part is smaller, so the buoyant force decreases and it becomes to weight of the object. Here the totally it is immersed, so the weight and the buoyant force both are equal. That means here in both cases, when the object floats inside the liquid or at the upper layer of the liquid, in the both cases the weight of the object, true weight of the object and the buoyant force acts on the object, both are equal. And so no resultant force acts on that object now. As these two are equal, then the apparent weight of the object becomes 0. Apparent weight becomes 0, but true weight does not become 0. True weight is equal to the buoyant force. That is why its apparent weight will be 0 when the object floats in rest. It may be totally inside the liquid, or it may be on the upper layer of the liquid. This is the floating and sinking condition of the solid. Thank you.